Hello, my dear JU warriors. Hello, my dear NEET warriors. Welcome aboard, welcome aboard, welcome aboard to the relative motion class. And I hope you guys are having a great time. Hello, Kola, Vedanjani. Welcome, Akshaya. Welcome, Alekhya. Welcome, everyone. All the NEET warriors getting up for the amazing class with your own physics educator, your mentor, your guide, your navigator, guys. And that's your Captain Shreyas. And in this particular lecture today, we are going to basically see the concept of relative speed, relative velocity, relative displacement, relative acceleration, kinematics. We are also going to see approach and separation. We are also going to see rainman problems, river boat, steamer problems, all of this in today's session. So make sure you have not just shown your attendance by smashing the like button, but also talk about this channel, talk about this your batch, talk about all the things that you get over here to all your friends, right, and your batchmates. Make sure that all of you are tuned in together and subscribe, and make sure you are a part of the Telegram channel as well. And when you love and when you show your affection, it means a lot to me as well as my team right over here. Remember, there is already a batch which is running for all of you, which is called as the Energized batch. Link is there in the description box. You can join my batch. Even if some part of the portion is over, you can still catch up. There are still many students who have covered up all the backlogs, because you get personal mentorship, doubt clearance, you get test series, you get assignments, you get DPPs, you get everything that you need for cracking the NEET examination. So that is the NEET Energized batch by your very own Avengers team. Link is there down below. Make sure you make the best use of not just the YouTube classes, but also the classes on the platform, right? So let's begin with the class. Hello Rebu, hello Darsan, hello PG Vijay, hello Asha, Medlife, welcome Kartika, nice to see you back. Hello Venkat, I hope you guys are doing great. Joel, hello, welcome. Nice to see all of you. Hello Sunlight. Sir, I'm not able to solve questions from the boat river problem. Yes, this session is definitely going to help you with that. Thank you for all the love. Ribu Garu, for all the love from Andhra Pradesh. Newton's laws of motion will be covered in one shot tomorrow. Yes, definitely. Hello Jenny. So let's begin with the awesome class with your Captain Shreyas. Now let's talk about what is the meaning of relative motion in general. Now, everybody would have traveled in train or bus sometime or the other. And has it happened that you looked outside the window, this is the window of the train, and you are seeing maybe another train, which is, let's say, over here. This is another train, this is another train, and suddenly you see that the train has started to move. The train has started to move. And then you also feel that maybe the train is not moving, maybe I am moving, looking through that window. Have you felt that? And then you realize that, oh no, that train was not moving, I was moving. Or sometimes you feel that, oh no, that train was actually moving, I am at rest. So all these kind of notions you get, that is because of a relative thing. Every time you look at anything in motion or at rest or acceleration or displacement, it's always with respect to something. Remember, motion is always relative. Motion and the concept of rest is a relative concept. You can never see anything at absolute rest. Sir, the earth is moving around the sun, sir. Sun is moving around the center of galaxy. Galaxy is moving around the center of all the galaxies. So there is somebody sitting over there nicely meditating, or I don't know, something. And that particular person is at rest. No. There is nothing like that. Everything is floating in space. Everything. When you see a car moving, it is with respect to the trees, the surroundings, the buildings around you. Correct? Everybody agrees with me? You feel on the earth that the sun is going around the earth. That's what people used to believe for hundreds and thousands of years. The earth is the center of the universe and everything goes around the earth. But if you stand on the sun, the earth goes around you. Correct? So motion is all relative in nature. That's what I want to say. Now that you understand that motion, the concept of rest, is a relative concept, how do I show it? Well, you always need something called as the frame of reference. You need something called as the frame of reference. The frame of reference, please realize that this is an imaginary concept. This is imaginary concept. It's basically your perspective, point of view. It's basically what the observer will see. What the observer will see. The observer can be anything or anybody. Maybe a person sitting inside a bus. Maybe a person flying in an aeroplane. Maybe a person underwater. Maybe an insect crawling beneath your bed. Or maybe you're just sitting on your chair. It could be anything, anybody. It's imaginary. You can, even if it is not a real thing, you can make a hypothetical person. Like we know who is our favorite hypothetical person, my dear students. Who is our favorite person? Put it up in the chat box. Wherever we need an observer, who do we take help of? Yes, we take help of Pandu or Champa. If Pandu is busy, then we ask Champa. Champa, can you please come? Exactly. Very good, Alekya. So it's an imaginary thing. It could be anything. So that is the meaning of frame of reference, your perspective of seeing things. Different observers, different frames may conclude different things. Example, you are saying Tata bye-bye to your friend. He is going in a bus. You say bye to him. He has carried his luggage, his suitcase. For him, your friend, the suitcase is at rest. But for you, the suitcase is moving with the bus. So different people will see different things. Everybody is correct. Nobody is wrong. Everybody is correct in their own point of view. Is that making sense? Is that making sense? Everyone with me on this? Great. Now, when I usually say the velocity of, let's say, a car, velocity of car is, let's say, 20 kilometers per hour in the northeast direction. Who am I referring to with, who is being compared with? When I say 20 kilometers per hour, what am I comparing it with? Whom am I referring it with respect to? It's always, when it is not mentioned, this 20 kilometers per hour is always with respect to the ground. With respect to the ground, or I would say basically the earth. It's always with respect to the ground or basically with respect to the earth. Is that clear? Yes. With respect to the trees, the buildings, the roads, the structures, the rocks, the mountains, all with respect to that. When it is not mentioned. But understand, indirectly it is with respect to the ground. But sometimes you might be like, the velocity of the car with respect to the train. Velocity of the train with respect to the rain. Velocity of the rain with respect to the clouds. Velocity of the ship with respect to a car moving in this direction. So velocity can always be with respect to something. So say for example, I write it down like this. Velocity of the car with respect to Pandu. With respect to Pandu. In this case, realize that Pandu is your frame of reference. Pandu is now your observer and car is being observed. Being observed. Is that right? Pandu is the observer, car is being observed. The way I write it is like this. The way I write it is something like this. Velocity of the car that is being observed with respect to whom? Pandu. VCP. That is the meaning of relative velocity of the car with respect to Pandu. That's how I write it. The first subscript is always the one which is being seen. The second subscript is the one which is written below, right? The second subscript is always the one from which you see things. The observer, the point of view, the perspective, the observer, the frame of reference, whatever you want to call it. Is that right? Yep. Awesome, awesome. Is that clear, my dear students? So these things, the nomenclature should be very, very clear. Similarly, if I say S12, what is the meaning of S12? It is nothing but the displacement of one with respect to 2. If I say A12, it is nothing but acceleration of one with respect to 2. If I say V12, it is nothing but velocity of 1 with respect to 2. In all the cases, the number 2, whatever that body, that object, that person is, 2 is basically your frame of reference. 2 is basically your frame of reference, and 1, the object numbered or labeled 1, is being observed. The motion of it is being basically studied, or it is being observed. Is that clear? Everybody with me? Awesome. Now, if I change the subscripts, interchange rather, then what happens? Look at this. If I say object number 2 is over here, object number 2 is here, and object number 1 is being studied, object number 1 is being studied, so I write velocity of 1 with respect to 2. This is nothing but your velocity of 1 with respect to 2. If I interchange the subscripts, see, like this, meaning now 1 is your frame of reference and 2 is being observed. You will see 2 doing exactly the opposite thing but of the same magnitude. If I am seeing the car going that way, that car will see me going exactly the opposite way with the same speed. So if I write V21, which is nothing but velocity of 2 with respect to 1, realize both of them are same in magnitude but opposite in direction. So I can always say V21 is negative of nothing but V12. So it is going to be negative of that. Keep this in mind. Not just this, this is also true for displacement, for acceleration, for anything. So I can also write this is minus A12, it's also minus S12, and on the left hand side I will write A21 and this will be S21. So this is always true. Be it velocity, be it acceleration, be it displacement, it always holds. So if you change the perspective, if you interchange the perspective, it will be opposite but of the same magnitude. So this is again a very, very important relationship. Is that right? Everybody with me? Yep, the negative of each other. Perfecto, perfecto. Awesomeness, my dear students. Moving on now, moving ahead. Imagine, I want to find these velocities. I want to find what is this relative velocity. And I know individual velocities. Then this is how it works. If V1 and V2 are velocities with respect to the same frame, with respect to the same frame of reference, then V12, velocity of 1 with respect to 2 as seen by 2, I will take away 2's velocity. When I am seeing with respect to 2 means, imagine you are an observer sitting in that object number 2. Object number 2 is now at rest. Now the whole world will be seen with respect to 2. So whatever 2's velocity will be there, you suck it away, you take it away. You take out 2's velocity from 1. So that's why it is nothing but velocity of 1 minus velocity of 2. You are taking away 2's velocity so that 2 comes to rest. So that is why that minus sign comes. Is that understood, my dear warriors? Is it very, very clear, my dear students? Pakka, 100%. So this is always going to be true. So this is a very, very important statement. Not just that, I can also say S12 will be S1 minus S2. I can also say A12 will be nothing but A1 minus A2, vector wise. This is all vector wise. So this is always going to be true. So I'm just going to block this off. Just to give you some examples so that you know how to calculate anything with respect to anything. So let's try this out. Okay. So let's just try out certain examples. Imagine this is your Pandu, and let's say we have Champa over here, a beautiful looking Champa. Yeah, she's wearing a nice red lipstick. Perfecto. Great. So first time I tell you, listen, Pandu is going like this. Second time also Pandu is going like this. Next time Pandu is going like this. Next time Pandu is going like this. Just taking some random cases. Let's say this is 10. Let's say this is 20. Let's say this is 30. Let's say this is 40. Then I will do the same thing for Champa also. Let's say Champa is going like this with a speed of 40. Let's say this time she is going like this with a speed of 10. Let's say this time she is going like this with a speed of 20. And let's say finally, she is going like this with a speed of maybe, 30. Just giving some random examples, okay? I've taken some random numbers. Now, what I want to do, observe carefully. I have to find velocity of Champa with respect to Pandu. Meaning, I have to take VC minus VP. VC minus VP. V12 is V1 minus V2. So, VCP is VC minus VP. Let's try this out. What is VC? Velocity of Champa. It is 40. Do you see that? It is basically 40. Minus. What is velocity of Pandu? It is again 10. So this will be 40 minus 10, which is nothing but 30. Is that right? Everybody with me? Very good, Alekhya. Very good, Leisure Bunny. Awesomeness. Proud of all of you. Okay. Somebody is very sad that Champa is going far away. Sir, please don't draw Champa going far away, sir. Pandu will be sad. Don't worry. If she goes away, she will come back also. That's how it is. Relationships. Okay. Yeah. So, Dr. Priya, whatever I am teaching here is more than enough, but you have to practice a lot, bacha. The theory, I am giving full-fledged, proper theory I am giving, but you have to practice a lot. That's what is required from you. Is that okay, Dr. Priya? Okay, next. In the second case, VC minus VP. VC is not 10, that's the catch. Because it is towards the left side, it is strictly speaking minus 10. Minus VP is basically 40. So basically this will be minus 50. Meaning that if you are Champa, you are seeing from Champa's perspective, Pandu will be seen going towards the left side. So VC is basically a 10 and VP is basically 20. Oh, sorry. What did I just do? My bad. Why did I put 40? So sorry. This was 20. My bad. This was minus 20. So this will be nothing but minus 30. Minus 30. Yeah. So this was minus 10. That is the velocity of Champa. Velocity of Pandu will be plus 20 because it is towards the right side. So right side is always positive. So VP, you will just put it as plus 20. So these equations are very sign sensitive. That's the something which you should be very careful about. Next thing, over here, if you look, Champa is going towards the right side. So plus 20 minus Pandu's velocity is minus 30. So this will be basically minus 30. So minus minus becomes plus. So this will become plus 50. This will become plus 50. Here, if you notice, 30 is towards the left side. So Champa's velocity will be minus 30. Minus Pandu's velocity is also negative. So minus 40. So this will become 40 minus 30, which is basically 10. This will be 10. Everybody with me? Exactly. So be careful. No, it is not minus 70. Be careful. It's velocity of Champa, which is minus 30. Minus velocity of Pandu is also going to be minus 40. Directions are very important. Sign sensitive. That's how you do this. Don't worry, we are going to solve problems as well. Now, if you understood till here that you have to be very careful with signs, okay, then let me give you the next part of this problem. If I ask you, what is the velocity of Pandu with respect to Champa? That means it will be VP minus VC. It will be VP minus VC. The only thing that will change is the order of the terms. So all these answers will be just directly negative. But if I have to solve it also, how will I solve? Observe, VP, velocity of Pandu is 10. So 10 minus velocity of Champa is basically nothing but 40. So this will be minus 30. Exactly, I am getting it opposite. Second one, velocity of Pandu is 20. Velocity of Pandu is 20. What is velocity of Champa? It is minus 10. It is basically minus 10. So what will this be? This will be nothing but plus 30. This will be nothing but plus 30. You can see it is minus 30 plus 30, exactly opposite. Then third case, Pandu's velocity is minus 30. So minus 30 minus Champa's velocity is plus 20. So 30, 20, that will become 50 but with a negative sign. Last one, Pandu's velocity minus 40. Pandu's velocity minus 40 minus Champa's velocity is minus 30. Champa's velocity is basically minus 30. So what will this become? This will become plus 30 minus 40, which will make it minus 10. So you can see again the answer is negative but of the same magnitude. Is that clear? Are you getting a hang of how to calculate the relative velocities if each of them are given? This will give you with the direction also. That means minus means left side, plus means right side. Minus means left side, plus means right side. If you find, sir, this is little bit lengthy, I will give you a trick. I will give you a trick by which you will not even worry about the signs. You will not even worry about the direction so much. Okay, you can immediately within 2 seconds you will get the answer. And if you want that, smash the like button right now. I want to see the likes going up quickly, fatafat. I want everyone to smash the like button if you want to see that 2-second trick. What is that 2-second trick? What is that 2-second trick? Right? If you want to know that, come on, keep smashing that like button. Yes, 2-second trick is as follows. Just see if they are going in the same direction. Let's say this is V1, this is V2, or basically this is V1 and this is V2. Or if they are going in the opposite direction, meaning this is V1, this is V2, or let's say this is V1 and this is V2, basically opposite direction. If it is same direction, if the direction is same, then the relative speed's magnitude will be basically V1 minus V2. V1 minus V2. Whichever is bigger, you take that first, minus V2. If it is same, put minus. If it is opposite, put plus. Here it will be basically V1 plus V2 will be that relative speed. As simple as that. Just add when opposite and subtract when it is same. When it is same, subtract. When it is opposite, add. That's all. Don't believe me? Let's try it out. Let's try it out. Don't worry. Let's try it out. Here, come back. Is the first case same direction or opposite direction? Is the first case same direction or opposite direction? Obviously same direction. Pandu is following Champa, no? Champa is going, Pandu is going behind Champa. Same direction. Same means minus. So 40 minus 10, what is it? 30. So you are seeing 30 units. Magnitude. You will get the magnitude directly. Look over here. Pandu is going here, Champa is going here. Opposite? Yes or no? Opposite. Opposite means add. 10 plus 20, 30. Oh, very good. Amazing. Okay, let's try out the next one. 30 this side, 20 that side. Opposite. What will you do? Opposite means add. Opposite means add. 30 plus 20, 50. Very cool. Last one. Pandu is coming back. Champa is following Pandu. Same direction. Same means subtract. 40 minus 30, 10. Wow, this is so cool, no? Isn't this amazing? Did you love this trick? Did you understand how to use this trick? So this is a very, very interesting trick, my dear warriors. So I'll just star mark it because it's a nice, important trick for all of you. Opposite means add, same means subtract. Opposite means add, same means subtract. That's all you need to remember. Great. Loved it? Perfect. After this, you will not face any problems. Great. Now that you know how to calculate these relative velocities, in 1D we can also extend it to 2 dimension. Trust me, it is not that difficult. If I tell you example, velocity of Pandu is 2i cap minus 3j cap. Velocity of Champa is minus I cap minus 4j cap. And then I ask you to figure out what is velocity of Pandu with respect to Champa. Velocity of Pandu with respect to Champa by definition is Vp bar minus Vc bar. So what is Vp bar? Velocity of Pandu 2i minus 3j. The whole thing minus velocity of Champa minus I minus 4j. That's it. So this is going to become minus minus is plus. So 2 plus 1 is 3. So 3i cap. Minus minus is plus. So 4 minus 3 is just 1. So plus j cap. So that is velocity of Pandu with respect to Champa. Directly. Just do normal vector subtraction. There is nothing great about it. Similarly, if I ask you what is the velocity of Champa with respect to Pandu, you can say it is directly negative of velocity of Pandu with respect to Champa. So it is just the negative of this. So it will be minus 3i minus j. That's the final answer. Is that right? Everyone with me? So easy peasy lemon squeezy. So easy peasy lemon squeezy. If you have 2D or 3D problem, you can still do it. There is nothing great about it. Okay, imagine somebody tells you acceleration of 1 is 2I plus 3k cap, and A12 is minus I cap plus 4k cap, example. Okay, and then you have been asked what is the acceleration of the second particle. What will you do? Just go simply by definition. I have been given A12. So what is A12? By definition, it is A1 minus A2. It is A1 minus A2. Substitute. Okay, we want to find A2, right? If I want to find A2, bring it on this side, bring this guy on that side. So therefore, A2 will be A1 minus A12. I've just shifted A2 here, shifted A12 on this side. Now I know what is A1. What is A1 from here? It is basically 2I plus 3k minus what is A12 right over here? Minus I plus 4k. So what will this be? 2I minus minus is plus, 2 plus 1 is 3. So 3I. 3 minus 4 is basically minus 1. So minus k hat. So that is the acceleration of the second particle. So we got it. 3I minus k. Wow, so many of you have given the right answer. Very good. Alikya Jenny, very good Pravina, Vedanjani. Awesome, yeah. Every time you girls are giving such nice proper answers. Very good, Leisure Bunny. Awesome, Shamsher. Very good. Great, great. So this is how you can, solve any problem of 2D, 3D, be it displacement, velocity or acceleration. Now let's go a step further and see if I can also use kinematics in relative. And I think you can. Just like, imagine, all right, there is a nice truck or something over here. Okay. And this truck person is observing somebody else from the other side, coming from the other side. Maybe there is a bus. Okay, coming from the other side, let's say like this. And you want to solve problems like how much time will it take to cross, or if they are going the same direction, how much time will they take to overtake, all these kind of problems. In all these kind of problems, okay, where trains are taking some time to cross, police guy is chasing somebody, how much time will it take to catch the thief, all these problems, standard procedure, make one person at rest, make one body at rest and observe the other. You can make any person at rest, it's up to you. You want to be the bus driver or you want to be the truck driver? Please let me know in the chat box. Please let me know in the chat box. Bus driver or truck driver? Bus driver or truck driver? Come on, my dear students. What do you want to be? I was expecting something else though. I was expecting, no sir, we don't want to be bus driver or truck driver. We want to be doctor, sir. Okay. Oh, kidding guys. Yes. Okay. You want to be bus driver? No problem. Doesn't matter guys. Okay. For the problem's sake, yes, we are ready to sacrifice for some time. So you can make any person or any body or any object at rest. So you can make anything as your frame of reference. Your frame of reference. So this person or this object or this body will be at rest. And basically you see the relative velocity. You will see the relative velocity. You will get the relative displacement. You will get the relative displacement. You will also get the relative acceleration. So now it becomes like a normal problem where everything is at rest, or you are at rest and you are seeing other things moving. Just like when you stand on the ground, you see that all the trees, objects, everything are at rest, but the body which is moving with respect to you. Just like you solve it normally, you will solve it here also. There is nothing great about it then. So you can still say that if the velocity relatively is uniform, if velocity is uniform, that means the relative acceleration is basically 0, then you can always use this. What is this? Relative velocity is basically your relative displacement. relative displacement upon the time taken. You can play around with this. Displacement is velocity into time. Time is displacement by velocity. It's up to you. Okay, so it's basically velocity is nothing but your displacement divided by time, but this displacement is a relative displacement. This velocity is also relative velocity. So you can play around with this. This works every time. Your standard 9th standard physics, right? Distance, speed, time, it's valid every time. Like a good example of this would be, imagine there is let's say a car. Okay, there is a car of length, example maybe 5 meters, maybe it is moving with a speed of 25 meters per second, and let's say there is a truck ahead. Okay, there is a truck ahead over here. The length of the truck, example, maybe it is I don't know, maybe 15 meters or something. Okay, and the truck is moving very slowly with a speed of just 5 meters per second. If I ask you how much time does the car take, the time taken to overtake, by the car, so how much time will the car take to completely overtake the truck? That's the question. So let's try to solve this. You can be the truck driver or the car driver, it's up to you. Doesn't matter, the answer will come out to be the same. I mean, it will be easier if you visualize that you are a truck driver. So if you become the truck driver in this case, you choose that as the frame of reference. So everything needs to be drawn again with respect to the truck. Now the truck is at rest, it's your perspective. So you will now see that the car which is there will come at a relative speed. What will be the relative speed? Can you guess? Because the truck and the car both are going in the same direction. When it is same direction, it is minus. Opposite direction is plus. Same is minus, opposite is plus. So same direction means minus. So it will be basically 25 minus 5, which is basically 20 meters per second. So the car's velocity will be 20 meters per second. Agree? Everybody with me? Okay. How much time will a car take to cross it? I know the speed, I just need to know the displacement. Think logically, my dear students. If this is the truck, the car starts to overtake when the front bumper just is close to the rear bumper of the truck, and eventually this same car has to reach here. Eventually, what will happen? The same car, right? It has to basically reach here. So when that happens, the front bumper is over here. The front bumper has reached here. The rear bumper is close to the front bumper of the truck. So how much has the car actually moved? It has not only moved the length of the truck, but it has also moved the length of the car. Length of the truck is 15 meters plus the length of the car is basically 5 meters. So basically you have moved basically how much? 20 meters. Is that right? Yes, you have moved 20 meters. Perfect. Is that understood? So the car's front bumper is close to the truck's rear bumper. You have to reach here. That means the length of the car plus the length of the truck both have to be overcome. Now you use your time is basically displacement. Okay, displacement by speed. This is relative. This is also relative. Everything is relative. Everything is relative to the truck. So what is the relative displacement? 20. What is the relative speed? 20. Answer is 1 second. My gosh, this is really quick. Zoop, it will go. 1 second only, the car will overtake the truck. That's how it is. Is that clear, my dear warriors? Is that understood how to visualize, how to solve these problems? You can also get problems where two trains are trying to cross each other. We are going to solve those kind of questions also. Not just this, but you can also use kinematic equations in these cases. If acceleration is uniform, that means basically acceleration relatively is constant, then you can use the kinematic equations like this. V relative is u relative plus acceleration relative into time. Okay, all those equations will now become relative equations. Relative displacement will be relative velocity into time plus half times a relative into t square. V relative square will be nothing but u relative square plus 2 into a relative into s relative. That's how you can write all the kinematic equations. Displacement in the nth second relatively will be u relative plus a relative by 2 into 2n minus 1. All these equations are also valid in relative frames. There is no harm in using them. Everything is valid. Okay, everything is valid. Let me give you an example on this as well. Let me give you an example on these kinematic equations. You already know these kinematic equations, just that remember, relative acceleration should be constant. Relative acceleration should be constant, only then it is valid. So let's say for example, there is a car over here. Okay, this is police, this is police, this is just an example, my dear students, and it starts from rest, and begins to accelerate at, let's say, 4 meters per second square. Let's say at 4 meters per second square. And let's say for example, there is a thief over here, and he is already in motion, and his speed is, let's say, 2 meters per second. Already his speed is 2 meters per second. Example, just taking some random example. And the thief, okay, is moving at a constant speed. That means the acceleration is not there. Or if you feel that the speed of the thief is very less, maybe I can put one number over here so it looks decent enough. And let's say for example, the separation between the two, maybe it is 20 meters. Initially. So the thief is moving with a constant speed. The police starts his vehicle and accelerates towards the thief. When will the police reach the thief? To catch him? That's the kind of question. So when will basically they catch the thief? That's the question. So to solve this kind of question, what will you do? Either you can become the police or you can become the thief. You can become the villain, you can become the hero. It's up to you. Okay? But after watching Vikram Vedha like movies, you will be like, sir, I want to be the thief. Sir, I want to be the villain. Villain is so cool, in Vikram Vedha. So anyways, so let's say you become anything, my dear students. You can become the thief, you can become the police. If I start writing down these values, like what is the relative velocity initially of the police with respect to the thief? Think about it. What is the velocity of police with respect to the thief? It is velocity of police minus velocity of thief. What is velocity of police? It is 0. What is velocity of thief? It is basically 12. So basically this will be minus 12 meters per second initially. Everybody with me? Agree? Perfecto? Awesome. You understand what I did? U12 is U1 minus U2. Initial velocity of police, rest. Initial velocity of thief, 12. So just put it here. Then acceleration of 1 with respect to 2. What is the relative acceleration? Or basically here in this case I am worried about acceleration of the police with respect to the thief. It is again AP minus AT. What is acceleration of the police? It is given to be 4. Acceleration of the thief is going with constant speed, so 0. So this is 4 meters per second square. Is that right? When they finally nab him, what will be the same? The thief and the police position will be same, but thief has traveled this much, police has traveled a lot more, 20 meters more. Their displacements will not be the same. So can you quickly guess what will be the displacement of the police with respect to the thief? Displacement of the police is behind me, I am the thief. I will see the police coming towards me. How much? Only 20 meters. Just think about it. Forget the earth. Police is behind me 20 meters. Slowly I will see the police come towards me like this. So how much has it moved? 20 meters in this direction. So should I not just put 20 meters right over here? Is that okay, my dear students? Everybody with me? Understood why it is 20? If you become the thief, you see the police is behind 20 meters. Finally, when they nab me, I will see the relative motion will be 20 meters. So I think the only equation which I can practically use is the second equation, s is ut plus half a t square. S is nothing but 20, u is nothing but minus 12, and this is nothing but t plus half into, what is acceleration? Acceleration is basically 4 and into t square. Now you just have to solve this quadratic equation and you will get the final answer. Like this 2 goes with this 4 and becomes 2. This 2 cancels with this 12 and this will become 10. So just rearrange this. So this will become t square minus 60 plus, minus 10 is equal to 0. Is equal to 0. Are you understanding it till this point? Everybody? Displacement, Sivagandhi, simple. You have to visualize over here. Thief is here, no? Police is here. How much will the police move? See, the thief might also move, but police has moved relative to the thief. See, only 20 meters. I know the thief is moving. I know the thief is moving. Even the police is moving separately, in fact more. But check the relative one. Check the relative one. If you are the thief, then for you, the police has only moved this much, 20 meters. That is the extra length which the police would have covered, because some part has already been covered by the thief. So remove that part. That extra part is the relative motion. Is that okay, everyone? That extra part is that relative displacement. Clear? Pakka? Awesome. Now you solve this and you will get the values of time. You will get 2 roots and that will be your answer. So that is how you solve these questions. The method, writing these initial acceleration, velocity, displacement, etc. That is the crucial part for solving these problems. Rest is simple maths. So I hope till this point everybody is clear on how to represent velocities in general. So we have seen V12 is V1 minus V2, S12 is S1 minus S2, A12 is A1 minus A2. We have also seen that if you interchange the alphabets or the letters, then it becomes negative but of the same magnitude. We have also seen that when they are in the same direction, you subtract. When they are in the opposite direction, you add to find the relative things. We have also seen that you can use kinematics. If there is no acceleration, then just velocity, displacement, time. But if it is accelerating like the one over here, then you can use kinematic equations. So that's how it works. That's how it works. Okay, cool. Chalo. Let's start solving some questions so that you guys get an idea of how to actually apply these things. There is a train of 150 meters length going towards the north. A parrot flies towards the south. Then how much time will the parrot take to cross the train? How much time will the parrot take to cross the train? Come on, think about it. This is the train. This is the train. 150 meters in length. 150 meters in length. And it is going towards the north. It's going towards the north with how much speed? 10 meters per second. 10 meters per second. You see that there is a parrot. Let's say that green parrot is over here. And it is going in the opposite direction like this. With what speed? With 5 meters per second. So I feel that if you make the train as your frame of reference, it looks very easy, because from the train's perspective, that particular parrot, because it is coming in the opposite direction, opposite means add, right? Opposite means add, right? So 10 plus 5, which is basically 15 meters per second, will be the relative speed, and the parrot will have to travel how much distance? Right from the engine till the end compartment. So if I am the train, I will be like cover entire length of my train. So basically it has to travel 150 meters. That is your relative displacement. So the time taken will be the displacement divided by that speed. Displacement is 150 and speed is basically 15. So therefore the time will be nothing but 10 seconds. Where is 10 seconds? Yes, option D. Perfecto. Is that clear? Is that clear, my dear students, how we did this? I sat on the train, I looked at the parrot. Because they are going in opposite directions, I added these speeds and came out to be 15. I have to cover the entire length of the train, which is 150 meters. So displacement 150, speed 15, that will give me the time. Straightforward. Let's do another question. How long will the passenger in the window of a train? It happens, right? You are traveling at 54 kilometers per hour. There is an opposite train coming in opposite direction, speed 36 kilometers per hour. How much time do you think you will see the train for? How much time do you think you will see the train for? Just think logically, guys. You are in the train. This is the window. So basically this will become my observer, my frame of reference. And that passenger, okay, that is the frame of reference. That passenger is already traveling at 54 kilometers per hour. 54 kilometers per hour multiplied by 5 by 18. How much will it be? Come on. Won't it be 15 meters per second? Won't it be 15 meters per second? The opposite, the train which is coming in opposite direction, this is basically coming at 10 meters per second. If you multiply it by 5 by 18, 36 by 18 is 2, 2 5s are 10. So 10 meters per second. So for that particular train in which the passenger is sitting, the train which is coming in the opposite direction, the relative speed will be how much? Because it is opposite, add. So it will be 15 plus 10, which is 25 meters per second. Everybody follows this. Opposite means it will be addition. Opposite means it will be addition. I have told you this very clearly. So the relative speed will be 25 meters per second. How much is the length of the train that has to go through you? Imagine how much length will go through that window. Basically, it is also given 150 meters. This is your relative displacement with respect to the window of the train. So if I am sitting in the window, I should say 150 meters crossing by me. That is the relative displacement for me. Is that understood? Is that understood? So that's it. So the time will be relative displacement by relative velocity, right? So it is 150 divided by 25. So 25 5 is 125, 25 6 is 150. So this is 6 seconds. So time is 6 seconds. Where is it? Option B. Exactly. I could see so many of you giving the correct answer. Very good, Jenny, Pravina, Alekhya, Vicky, awesome, Priyanka, Leisure Bunny, very good, Sunlight, very good, Shamsher, very good, Vedanjani, very good, awesome. That's the correct one. Is that clear? Every warrior, NEET warrior is understanding how to do these problems. Initially it takes some time, but after solving some 20-30 problems on your own, trust me, you will be like, sir, I will do it orally. Why are you doing all this? I'm doing all this because I'm teaching you. I'll do all the steps for you. Okay. So let's do the next question coming up on your screen. What does it say? Two kids are going from home to school. Which of the following statements about the relative motion is true once both of them started moving, assuming 1D motion? One student goes like this, one student is going like this. This is position versus time graph. Acha, we know that the slope of position versus time graph gives you velocity. Now in these two graphs, it's a straight line. That means the slopes are basically constant. That means, this is just by observation, that means the velocities are constants. Velocities are basically constants, but different constants because their slopes are different. So if I try to find their relative velocity, it will be v1 minus v2, which will be some constant 1 minus some other constant 2. So this will be a new constant. So that means the relative motion is a constant, but it is not 0 obviously, because both these numbers are not same, because the slopes are not same. So it's a non-zero constant, I believe, which is option D. Yes, it is option D, Alekhya. Correcto, perfecto. Yes, Priyanka, that's the correct answer. Clear? Everyone with me on this? Okay. Slope gives me velocity. Slopes are different. So when I subtract the slopes, I will get some value which is remaining. So that's why it is non-zero, but it will be constant because both these numbers are constants. That's it. That's very straightforward. Okay. Now, sometimes you might be also asked questions on approach and separation. It's very similar to finding relative velocity only. Just imagine, I tell you, there is one particle going like this with v1 speed, another particle going like this with v2 speed. So basically they are approaching each other. This is basically approaching each other. So if I ask you, at what rate is the distance between them decreasing? Rate at which the distance between them decreases. The rate at which the distance between them decreases will be the relative speed itself. If you observe carefully, V1 and V2 are opposite, so the relative speed will be V1 plus V2. So it is basically relative speed, which is in this case V1 plus V2 only. So that is also called as the relative velocity of approach. Relative velocity of approach, if you notice. They are approaching each other. If this guy is going with 5, this guy is going with 10. So 5 plus 10, 15 meters per second. The distance is reducing every second. Every second 15, 15, 15, 15, 15, 15. Because this is going 5, this is going 10. This is going 5, this is going 10. So that's how the approach velocity is relative to each other. Is that okay? Everyone with me? Is that clear? Perfect. Similarly, you can do for separation also. There is nothing different. Imagine maybe, I don't know, let's say this guy is going here, this guy is going like this, but maybe with less speed. Maybe this is V1, this is V2. So the distance between them is increasing. So this is the relative separation. This is the relative separation. So rate of change of separation, rate of change of basically separation, rate of change of separation, okay, rate of change of separation. In this case will again be the relative velocity, but the way I have shown the diagrams, because they are going in the same direction, it will be nothing but V2 minus V1, same means subtract. So if this is 20, if this is 5, this is 20, this is 5. So you will see the distance between them will keep increasing because the one in the front is moving fast, the one behind is moving slow. So we will see the separation between them will increase. So this is 20, this is 5, 20 minus 5 is 15. So every second the distance will increase by 15 meters. 1 second, 15 meters, 15 meters, 15 meters. That's how things will work. Is that okay? Everyone with me on this? Everyone with me on this? This is how separation as well as approach works. Separation as well as approach works. Sometimes they can ask you, what is the closest approach? What is the farthest separation and stuff like that. So whenever you get problems like that, which is very, very rare in NEET, especially very, very rare. So for closest approach, or for farthest separation, what will you do? You choose any frame, okay, you make anybody as the frame of reference. So this is your observer, and you look at the body, okay, maybe it is going away from you, maybe it stops and turns around. When it stops, that's when this will be your max separation. This is when the relative velocity will be 0. It's going away with respect to you, it stops, the separation stops to increase and it turns back. That is your max separation. The exact opposite will also work. Maybe there is a particle coming like this, and it stops, it turns around and goes like this. This is precisely the point again when the relative velocity will become 0. This distance will be the minimum distance of approach. That's it. This is the closest distance between the two particles. After that, again they start to separate out. Is that clear? Is that clear, my dear warriors, how this is? So if you are, imagine you are Pandu, Champa. Champa is going far away. And then you shout, I love you, Champa. Then Champa, she realizes, okay, Pandu loves me. So she will turn back. That is the farthest separation, correct? That is the farthest separation. So the opposite also. Champa has started coming close. She is very happy to meet you. And then as she comes close, you are like, Champa, you're looking fat. That's it, Champa will get furious, angry. She stops, she starts running away. That's the closest distance which Champa came to Pandu. That's how you can look at it, if you visualize it. Is that okay, my dear warriors? Did you understand? Did you visualize this? Pakka 100%. Can we move ahead? Let's see one question maybe. Police is chasing a thief at 50 meters ahead, and in 10 seconds the distance between them reduces by 6 meters. What's the distance between them in 25 seconds? What's the distance between them in 25 seconds? No, Champa will not even slap Pandu. That's it. Tata, bye bye. Ignore. Blocked. Contact list blocked. So what will happen, my dear students? Come on, think about it. Police is chasing a thief 50 meters ahead. So this is police. This is 50 meters. This is the thief. So the distance between them reduces by 6 meters every 10 seconds. So what is their relative speed? What is their relative speed? 6 meters in 10 seconds. So that is 0.6 meters per second is the rate of reducing the separation between them, right? The separation is slowly reducing every second 0.6 meters, 0.6 meters, 0.6 meters, 0.6 meters. So think about it, in 25 seconds, the separation reduces by how much? Think about it. Every second 0.6 meters. So in 25 seconds, how much? So 0.6 meters per second into 25 seconds, how much will it be? 150, shift one decimal, it will be 15 meters. So it reduces by, the separation reduces by 15 meters. So what it means is that police will move ahead by 15 meters. So what is their actual separation then? What will this be? Come on, think about it. This will be nothing but 50 minus 15, which is basically 35 meters. So 35 meters is there as option C for Captain Shreyas. The Panda, what am I doing? Am I not covering the syllabus? You're telling me whatever I'm doing. If I'm teaching, you're like, sir, please teach. If I'm standing, you are like, sir, please stand. What is this? The Panda, what are you saying? Man, I'm obviously covering the syllabus. Okay, cool. Understood how the separation and approach velocities basically work, right? So yeah, that's the correct answer for this particular question. Imagine I give you a question like this. Pandu is moving like this. With the speed of, example, maybe 5 meters per second. Champa is coming from the opposite side. With the speed of 15 meters per second. But she also has an acceleration like this at maybe, I don't know, maybe 2 meters per second square, example. So what happens is Champa comes close and stops and she turns away. Question is, when is she closest? When is she closest to Pandu? Champa is coming close, Pandu becomes happy and Champa asks, how am I looking? And Pandu says, you are fat. That's it. She decelerates, she stops, she turns away, she runs away also. So when are they closest? That's the question. So try to do this problem from Pandu's perspective. Let's take Pandu frame of reference. Okay, Pandu is our frame of reference. So everything with respect to Pandu, my dear students. Let's try this out. Come on. What is the initial velocity? Of Champa with respect to Pandu? So UC minus UP. Come on, do it properly. UC is basically minus 15. UP is basically 5. So this will be basically minus 20 meters per second. Everybody with me on this? Perfecto. What is acceleration of Champa with respect to Pandu? That is basically AC minus AP. What is acceleration of Champa? It is plus 2. What is acceleration of Pandu? He is going constant speed, so 0. So this will be basically 2 meters per second square. Because Pandu is going with constant speed, so there is no acceleration for Pandu. Lastly, think about it. When they are closest, what will be 0? Come on, my dear students. The relative velocity. So velocity of Champa with respect to Pandu will be 0. The relative approach. All right. their relative approach velocity will become 0 when they are the closest. Just like I have showed it to you over here, the relative velocity will be 0. So just use that and let's try to solve the problem using some kinematic equation. The best kinematic equation at play over here is V is equal to U plus AT, I believe. Final velocity is 0. Initial velocity is minus 20. Acceleration is basically 2 and time I do not know. Shift that 20 over there. 20 is equal to 2t. So t is basically 10 seconds. That's the answer. After 10 seconds they come the closest and then they start going opposite. Won't it be plus 10? So magnitude, study NEET, magnitude wise it will be 20. Think about it, they are going in opposite direction. So 15 plus 5 will be 20. So magnitude wise it will be 20, direction wise it is negative. The direction I get by using the proper vector equations. So the trick which I told you always gives me the magnitude. The sign you can only get it with this proper equation, keep this in mind. And for using kinematic equations, I need to know the proper signs. That's why I did not use my trick. I used the proper method only. And the proper method is not that difficult. I mean, it just increases one step because you have to get the sign properly. Is that okay? Study NEET and everybody else. So my trick, you have to use it only in certain cases, not every time. Perfect? Awesome. Great, my dear students. It's a rainy season. So we need to see how to protect ourselves from the rain. Wearing a raincoat can solve all the problems and can completely avoid these problems in physics. But let's say I don't want to wear a raincoat. At least I don't like to wear a raincoat yet. It is very tedious to wear it, remove it. How many of you like wearing raincoats versus umbrellas, carrying umbrellas? Come on, let's see. Umbrella or raincoat? Put it up in the chat box. I want to know, what is your favorite? I'll tell you what is my favorite after that. It is neither umbrella, it is neither raincoat. It is neither umbrella nor raincoat. You know what it is? Directly get wet in the rain. Are it's okay. Umbrella, everybody loves umbrella. Neither, very good. Akshaya. Thank you so much for relating with me. Yes, I like to directly go in the rain and it is fun, right? So, awesome. No sir, my parents don't allow, I will fall sick. You will fall sick once, twice, after that you will develop resistance. You are doctors, who knows it better? Okay, but don't get wet in the rain every time, it's bad. So let's understand what is exactly the procedure. See, if the rain is falling vertically down, obviously if I am standing with the umbrella, I will hold the umbrella stick parallel to the rain. I will hold the umbrella stick parallel to the rain so that I can protect myself. So this is your Pandu. He will be very happy because he is not getting wet in the rain. But if the rain is falling at an angle and the Pandu is standing, then you will obviously hold the umbrella also like this. The stick will be again parallel to the rain. So this is our Pandu then. Again very happy, he will not get wet in the rain. That's how it works. Everybody agrees with this? Awesome. But the problem happens when imagine Pandu is running. Maybe Champa is in front and Champa is getting wet in the rain, or he has to meet Champa, so he is running in the rain, correct? So when he is running like that, and let's say the rain is also at an angle, some crazy angle like this, okay? Now in such a case, how will he hold the umbrella is the big question. How will he hold the umbrella is that big question, because there are many possibilities. Will he hold it like this? Will he hold it like this? Will he hold it like this? Meaning, will the stick be like this? Or will it be like this? 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 Wow, looks like Pandu has a glow over him, right? So that is the basic question of a Rain Man problem. Now the idea behind that is, if Pandu is at rest, then it is a very simple problem, because the rain is either falling like this or at an angle. You hold the stick accordingly. That means if I see or feel from what Pandu perceives, basically from Pandu's perspective, however the rain falls, if I hold the umbrella like this, my problem is solved. So always observe from the Pandu's frame. So the solution to this is observe from the man's perspective. Observe from that person who is moving, from the man's perspective. That's all. That will give you the idea of how you should hold the stick. Let's try to see this. Let's try to see this with an equation. Okay, so this is how it goes. Velocity of the rain with respect to the man, VRM. What should I write in the front? Everybody spam the answers in the chat box. Just like I told you, what is V12, A12, S12? Quickly spam the answer in the chat box. What will be VRM in terms of VR and VM? What should I put? Who should I put first? Who should I put next? Who should I put minus with? Come on. Exactly, Shiva Gandhi. VR minus VM. Very good, Alekia Priyanka. Awesomeness, my dear warriors. It will be VR minus VM. Perfecto. Just like V12 is V1 minus V2. Why not VMR? Mister. No Mister. It is RM. Why not Mister? Because I want to find velocity of the rain with respect to the man. From the Pandu's perspective, from the person's perspective. How will he see the rain? That is why always VRM is VR minus VM. So if I tell you that the rain is falling like this is velocity of the rain. Let's say I tell you, listen, Pandu is going like this. Pandu is going like this. VM is like this. Oh, but wait a minute, I have to take minus VM. So minus VM will be a vector like this. This will be minus VM vector. Add this with VR vector. Okay, how do I add it? Simple. This will be nothing but your VR vector. So this will be nothing but your minus VM vector. So therefore, this by triangle law of vector addition will be VRM vector. This is the relative velocity of the rain with respect to the man. That means my stick should be held like this. So this is how I will hold the umbrella. This is how I will hold the umbrella. Is that clear, my dear warriors? Is that clear, my dear warriors? This is how you will hold the umbrella. So this is how the stick would be. Check this out. Clear? It's now a very simple problem because it involves triangles. So you can use the properties of triangles. If it is a right angle triangle, you can use Pythagoras or trigonometric ratios. Don't have to use IJK components every time. You don't have to struggle so much with vector subtraction formulas. If you draw the diagram, trust me, it becomes very easy. I have a question for you. Is it possible that you are running in the rain and you have to hold the umbrella straight? Is that ever possible to prevent yourself from getting wet? Just think about it. Is that possible somehow that you are running in the rain and you have to hold the umbrella straight? That means you perceive the rain to fall straight downwards. Is that even possible? Is that even possible is my question. Think about it. Okay. So for me, the velocity of the rain with respect to man is like this. Is it possible? Yes, definitely. Somebody is saying no. Trust me, it is possible. How? Imagine I show minus VM like this, minus VM vector like this. So obviously the rain vector will be, let's say, like this. So the rain vector is like this. That means the rain is falling like this. The rain is falling like this. VM negative is this way. That means the person is going that way. That means the Pandu, that person, is actually moving in this direction. So the rain is falling like this behind you. It's coming from, you're walking like this, it's coming from behind. Okay. Then you will have to hold the umbrella most likely like this. If this triangle is formed like this, that means this should be exactly 90 degrees. Then you will see that you will have to hold the umbrella like that. Is that crazy? You know? Very interesting to visualize also. The rain is coming from behind. You are somehow managing to move with almost the same velocity with which the rain is coming, ahead or behind. So if you match that rain velocity in the horizontal direction, you will only see the vertical velocity of the rain. And that's why you have to hold the umbrella vertically up. So that's how this works. Okay, beautiful. Let's solve some questions so that you warriors get some idea on this. Observe this question. Trust me, it is very simple. Rain is falling down with speed of 4. Man is walking in the rain with a velocity of 3. The rain will fall on the man with a velocity of how much? Okay. There are multiple ways of doing it. Let's say I show you this particular way. The rain is falling vertically down with 4 kilometers per hour. So this is velocity of the rain, which is basically 4 kilometers per hour. Then the man is moving with 3 kilometers per hour. The person is moving with basically 3 kilometers per hour. Let's say maybe like this. Okay, so velocity of the man is basically 3 kilometers per hour. I have to find the rain's velocity with respect to the man. Rain will fall on the man with what velocity? So to do that, I have to take VRM. And how does VRM work? VRM is always VR minus VM. So take the negative of this vector. The negative of this vector will be basically like this. This will be minus VM vector. This is VR vector. VR plus the negative VM by vector addition will be this vector. So this would be your VRM vector. And I know this is 90 degree. This is 4. This is also going to be 3 only, no? Magnitude wise, how much is it? It's 3. So how much will VRM be? Use Pythagoras. How much will VRM be? It is hypotenuse. So it will be magnitude wise root of 4 square plus 3 square, 16 plus 9, 25. So it will be 5 kilometers per hour, which is option D. Which is option D. Exactly. Is that clear? Is that clear, my dear warriors? Awesomeness. Why are you spoiling the name of Kashmiris? Kashmiri students are so nice. So stop calling yourself a Kashmiri and doing all this nonsense. Okay? Concentrate on the class or leave the kids alone over here. Okay? Come on guys. Let's do the next question coming up on your screen, and here it is. A man sitting in a bus. A man sitting in a bus traveling in a direction from west to east with a speed of 40 kilometers per hour observes that the rain is falling vertically down. Observes that. Observes means with respect to him. Then the other man on the ground will see the rain. That means the actual velocity of the rain will be how much, or in what particular direction. Person in the bus moving from west to east. That means velocity of the man is like this. So this is west direction to basically east direction. That is how VM is. So minus VM will be like this. So minus VM will be like this. Okay. He sees that the rain is falling downwards vertically. That means VRM is like this as per the question, vertically downwards. So this is basically 90 degrees. So the only vector remaining is VR vector. So VR vector will be like this. This will be VR vector. VR plus negative VM will be VRM. VR with minus VM gives you VRM, vector addition, triangle law. That's all. That's all. Is that right? Everybody with me? Everybody with me? Yep. How do you choose the direction of the man? See, even if, not this question, but in the previous question also, even if I had chosen it to be the other way around, the same triangle would be made like this, no? What will be the difference? You will have this like this, you will have this over here, and you would have this over here. Will the magnitude change? Will the magnitude change? No, right? So it doesn't really matter how I chose it. So this is minus VM, and this would be your VR, and still this would be your VRM. Here the question was only about the magnitude, so it really didn't matter. Otherwise, they would mention it to you which side is he moving. Like in this case, it's mentioned west to east. So minus VM will be east to west. Is that clear? Everybody with me? Shiva Gandhi, is that clear? Okay. So how is the rain coming? How is the rain coming? The rain is coming from the west side to the east side. West side to the east side at an angle. So how is the rain coming? Falling at an angle from west to east. Exactly, option B. West to east. You can see that with an angle. You can see that there is definitely an angle over here. Clearo? Understoodo? Pakka? Guarantee? Shall we move ahead? Loving these classes, loving my classes, loving the schedule of your Conquer batch. Okay, then you should definitely let me know in the comments after the session is over. I'm going to read all your comments, all right? So make sure you are not just subscribed but also liked, and also I want every student to comment after the class. It means a lot to me. Okay, when I see your comments, apart from the likes, it really makes my day. Because yes, I put in so much effort and my students love this. I feel like doing more. I'll do many things for all of you. Trust me. Okay, great. Let's move to the next question. Man is walking due east at the rate. So direction is mentioned here. Okay. Rain appears to come down vertically to actual rain's velocity. Okay. So as per this question, Vm is this way towards the east. How much is the speed? 2 kilometers per hour. 2 kilometers per hour. So minus Vm will be like this. Magnitude wise it will still be 2 only. Magnitude length wise it is still 2 only. Rain appears to come down. Rain appears to come down. That means your basically VRM is given. VRM is also given to be 2 kilometers per hour. So where will the rain's velocity be? Obviously rain's velocity has to be this one. This is the velocity of the rain, because VR minus Vm is VRM. A vector plus B vector is C vector. VR vector plus negative Vm vector is VRM vector, right? VRM is VR minus Vm. So I got it. So I can see this is 90 degrees. So VR magnitude wise will be nothing but root of 2 square plus 2 square, which is basically 2 root 2. So 2 root 2 kilometers per hour is there in option A. Also notice this is 2, this is 2. How much will this angle be? How much will this angle be? Just take tan theta. Tan theta is opposite by adjacent. Opposite by adjacent it is 1. So theta is basically 45 degrees with the vertical. So the rain falls at 45 degrees with a speed of 2 root 2 kilometers per hour, which is option A, of course. Option A, of course. Everybody with me? Got it? Pakka, 100%. Clearo. Very good. Shamsher, Pravina, Alekhya, Priyanka. Very good study, NEET. Vedanjani, very good. Clear. Let's move to the next type of problems, and that is plane moving in wind, or river is there and a person is swimming, or there is a boat trying to navigate its way in a river. All these problems are similar. All these problems are similar. So instead of water, you can make it the wind. Instead of swimmer, you can make it the boat. Instead of boat, you can make it the aeroplane. Aeroplane is moving through the wind. Wind is going like this. How will the actual velocity be? The boat is trying to go like this. The river is trying to push it here. So what will be the actual velocity? And if you have seen the news channels these days, in the last few weeks, there have been, heavy, there have been very, very bad things which have happened, in many parts of the country and the world, where there were floods and heavy rains. And because of that, you would have seen those visuals of how the river is flowing and how maybe a boat or a person trying to swim, is trying to go in a particular direction, but the river is trying to pull or push that particular person in another direction. So the same problems we are trying to go into solve over here. All right. So river, man, boat, or plane with wind. All these problems are very, very similar. That's what I want you to appreciate. First of all, let me make you guys acquainted with the notations. I will use U symbol. I will use U symbol for the velocity of the boat or the swimmer, or the basically plane, aeroplane, in still water or basically air. What do I mean by this? You take a swimming pool. Isn't the water still? Obviously the water is not flowing, right, in a swimming pool. Yeah, there is some small circulation, but as a whole the swimming pool is at rest. It's not like the swimming pool is moving in some direction. So if you try to swim in a swimming pool, you will get some velocity. That water is still. So in that still water, what is your swimming speed? or what is the speed of the boat, or basically if it's stationary, the air is stationary, then with what speed will the aeroplane go? That is the meaning of this particular U. Is that clear? Is this notation very, very clear? Next notation. W is the actual velocity of the river, or basically I would say the water, or if it is a plane, then it will be basically air. Wind is moving 50 kilometers per hour in the north direction, or the river is flowing from west to east at 6 kilometers per hour. So that is the velocity of the medium, the water or the air. Okay, that is W. The last one is V symbol. That is the velocity of the boat or the swimmer or the plane with respect to the ground. That means what will be the net velocity. So this is more like the net or basically the resultant velocity. This is the resultant of both these effects. The water will also push or pull that person or the boat. Even the person is trying to swim and navigate his way through. He is applying some strokes. So definitely both of them will have some role to play over here. Agree? So can I then say V bar is equal to U bar plus W bar plus basically W bar. So this is the main governing equation, my dear warriors. V bar is U bar plus W bar. It's the net or the resultant velocity. So if I have to show vectorially, imagine the person is trying to swim in this direction, but the river or the water is trying to pull him in this direction. Then the resultant velocity of the swimmer will be basically like this. This is the resultant velocity. That's how it works. If you know this triangle or this equation, or you just understand the core meaning of it, also you can definitely write down this equation or draw this triangle. Is that okay, everyone? Very, very important notations. Now let me play around with this. There are two special cases for in 1D, and there are again two special cases for 2D. So first let's talk about one dimension. Motion. The first one is where the river is flowing in a particular direction, or the wind is blowing in a particular direction, and you try to move in the same direction. So you are also going in the same direction. This particular I would say scenario or case is called as downstream. This is called as down the stream. In such a case, because both the speeds are in the same direction, the total velocity magnitude wise will be simply U plus W. When you are going down the stream along with the river. The exact opposite will be up the stream. So let's say the river is trying to go this way with W velocity, and you are trying to go in the exact opposite direction with U speed. Then such a situation is called upstream velocity, and then you get the net velocity to be modulus of U minus W. I don't know who is more, who is less. So if the swimmer moves faster than the river, then it will be the swimmer will be able to go in this direction. If the river is fast, the swimmer is slow, then in spite of the swimmer trying to swim against the current, he will be carried like this with W minus U speed. By chance, W and U are same. That means the swimmer and the river both are trying to move opposite to each other with the same speed. The person will be at rest. Imagine what a scenario it will be. Person is trying to swim at 6 kilometers per hour. River is also going at 6 kilometers per hour. Opposite directions. They both will cancel and you will get zero velocity. Is that right? Everybody with me? Understood? Clear? Perfect? Chalo. This is basically one dimension. And there are questions on one dimension motion also. Let me just show it to you, and then I will go to 2D also. A steamer moves with velocity of 3 inside the river water whose speed is 2. calculate the total time of the journey if the boat travels 2 kilometers in the direction of the stream and then back to its place. 2 kilometers in the direction of the stream, that means it is down the stream. And then back to it, that means it is upstream. So there is both downstream as well as upstream motion. So if the boat starts from here, it goes down the stream and it reaches here, and then again it starts from this point and it comes up the stream over here finally. So that is the entire journey. This total length is given to be 2 kilometers on either side. 2 kilometers on either side. When you are going down the stream, obviously the speeds will add. Down the stream the speeds will add. So it will be 3 plus 2, which is 5 kilometers per hour. But when you are going up the stream, bigger speed minus smaller speed. So it will be 3 minus 2, which is 1 kilometer per hour. 1 kilometers per hour. That will be your speed. So to find out the total time, time taken to go down plus the time taken to go up the stream. Time is distance by speed. Time is always distance by speed. Distance is basically 2 kilometers. Speed is basically 5. Distance is 2 kilometers. Speed is basically 5. Similarly, time to come up, distance is basically 2. Speed is basically 1. 2 by 5 is basically 0.4 plus 2. So that is 2.4 hours. 2.4 hours is option C. C for Captain Shreyas. Yep, there you go. Hello Gopika. Yes, yes. Awesome, awesome. Okay, I hope this is very clear. Awesome Pravina, very good study NEET, very good Alekhya. Very nice. Let's move to the next question coming up on your screen. Okay, but for that I think we'll have to go to 2D velocity. But even in 2D, this problem, you can solve it even if I have not taught you much on 2D, or I have not discussed too much on 2D right now. I've just discussed 1D, but still you can solve this because you know this particular equation. And I want to see if you can actually solve this using this particular equation. V bar is U bar plus W bar. Just remember this equation and I feel that you can still solve this. A boat is moving with a velocity of this much with respect to the ground. That means, is this 3i plus 4j? Is this 3i plus 4j? Is it u, is it w, or is it v? As per my notations, as per the notations that we have discussed, is it the velocity of the boat with respect to still water? Is it velocity of water? Is it velocity of the actual boat with respect to ground? So is it u, v, or w? It is definitely v because it is with respect to the ground. So this is nothing but v bar. Excellent. The river water's velocity is minus 3 minus 4j. So minus 3i minus 4j. So what is that? Is it u, is it v, or is it w? He's already taken. Is the actual velocity of the medium, the water, the river, the air, whatever it is. So I have to use the symbol w. Correct? So the question is, what is the velocity of boat with respect to water? That means u vector is asked. U vector is asked. So we all know how the equation works. V is nothing but u plus w. So therefore, u will be nothing but v minus w. Take w on the other side. So v is nothing but 3i plus 4j minus w. W is nothing but minus 3i minus 4j. Minus minus becomes plus. 3i plus 3i will become 6i. 4j plus 4j will become 8j. So 6i plus 8j should be the answer. Yes, it is. That's how you solve these questions. Next chapter is tomorrow. Yep. Next chapter is tomorrow. Yeah. That is Newton's laws. Is that clear? How to solve these questions? You just have to use these equations. Where is it gone? Here. And if you know what means what, the symbols, if you understand it logically, it is very simple. Speed of the water plus the speed of the swimmer together gives you the resultant velocity of the swimmer with respect to the ground. That's all it is. Now let's go to 2 dimension. We had done 1 dimension. Okay, let's go to 2 dimensions. So let's talk about 2 dimension motion. So usually in 2 dimension motion, what happens is, okay, you will be given the river like this. This will be the banks of the river separated by some distance d. The swimmer will try to go somewhere, okay, in some random direction. The river will try to pull him somewhere in some direction. you will get the resultant velocity of the swimmer. You will get the resultant velocity of the swimmer. Remember, V is technically nothing but U vector plus your W vector. That is your net velocity. So if this is the net velocity, and if I call this as the starting point O, then I will get an exactly opposite point over here, which is A. And because the resultant velocity is like this, the swimmer or the boat or the plane, whatever it is, it will go in this direction and it will actually reach over here. So what are these points? Let's try to mention that. O is basically the starting point. The starting point. A is a point which is directly opposite to O on the other bank. B is the point where he actually ends up reaching. So he reaches at that point B on the other bank. Now some things which you should be very well aware of. How much time do I take to cross? How much time I take to cross the river? That will only depend on one particular velocity, not the entire velocity, only a particular component of the velocity, because I have to go from this bank to this bank. Only worry about the y component of the velocity, my dear students. So if I divide this into two components, one here and one here, this would be the y component, this would be the x component. Everybody with me on this? This would be the y component, this would be the x component. Everyone with me on this? So if I ask you, you have to go from this bank to this bank, just look at it as a 1D problem in y-axis. This is the y velocity, you have to go here. This is the y velocity with which you have to go, and you have to cross a distance d. So time will be distance by speed. So should I not write the time as the distance by Vy? Distance by the net velocity is y component only, nothing else. Everyone with me on this? That's the time taken to cross. Very, very important formula. You have to know this. Time taken is the distance between the banks upon the y velocity. Very simple. Next, this point to this point, opposite point to the point where he reaches, that distance is basically called as the drift. This A to B distance is called as the drift amount, or how much has he drifted. He got drifted in the river. He got carried by the river from point A to point B. That AB distance will depend on this velocity. I am moving with this speed, and I reached B. So in the x direction, how much did I displace? That AB, if I call it as x, that value of x should be only the x velocity into the time which I spend inside the river. Time into the speed will give me the x displacement. That's it. So that is this particular formula. So if you know these two things, or you understand these two things, solving river, boat, man problems becomes very, very easy. It becomes very, very easy. Is that okay, my dear warriors? Did you understand both these terminologies for two-dimensional motion? Give me a thumbs up. Then I will show you two special cases in 2D. This is general case. This is very general case. Now I am going to show you two special cases. Cool? Give me a thumbs up. Okay. The first case is, imagine this is the bank, this is the other bank. Okay. There is some distance between them. And I want to cross the river in the shortest distance. In the shortest distance. That's the situation number one. That's the situation number one. What is the shortest distance between two lines? Here the two banks are two lines. So what is the shortest distance? You drop a perpendicular. So basically, the shortest distance between them is nothing but the perpendicular. Correct? So I need to go in this direction. I have to go in this direction. That means my actual velocity should be like this. Everybody agrees with this? Awesome. 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 Now, my next point is, how will you try to move so that even when the river is flowing, see, the river is flowing maybe like this. In spite of that, you end up going straight. How will you try to swim? Will you try to swim slightly towards the right side or try to swim slightly towards the left side so that your resultant velocity is in this direction? Come on, my dear students. Think about it and tell me. Think about it and tell me. How will you try to swim? Slightly towards the left, slightly towards the left, so that you are going against the current partially, you are balancing the current partially, and only the velocity in the y direction is remaining. So can I say I will try to swim like this? That means this will be u vector. The river will try to pull me here, that will be the w vector, and the resultant comes over here. So naturally, can I also say that this is 90 degree, and let's say I call this angle as theta over here. That's how it looks like. That's how it looks like. So the resultant velocity will be perpendicular, u will be here, w will be here. Great, amazing, amazing. Now you can use trigonometry and say, or Pythagoras and say, that v square plus your basically w square will be nothing but your u square. That is one equation which you can write using Pythagoras. If you know these two, you can find this. If you don't know these two, you can find this, and so on and so forth. Not just that, you can also find theta over here, because if you notice, tan theta, or even let's say I take sin theta, sin theta will be opposite by adjacent, hypotenuse. Opposite is w and hypotenuse is nothing but u. So sin theta is w by u. You can find cos theta, you can find tan theta. It's completely dependent on the problem. So you can find the angle at which you should swim so that you end up going straight. The angle at which you should swim with respect to the vertical so that you end up going straight. Not just that. If I ask you what is the time taken to cross, what is the time taken to cross, what will your answer be? Time is always, I have told you, distance by Vy. Distance is d. What is the vertical speed? What is the y speed? It's completely v. There is no component of v. So it will be directly v only. If you want, you can just write this v as u square minus w square's root. U square minus w square's root. Is that right? Yeah, from here you can shift it over here. V will be root of u square minus w square. Everyone with me? Understood? And if I ask you what is the drift in this case, the answer will be 0, because you aimed here, you ended up reaching here. So point O and point A are directly in front of each other. So there is no drift. There is no drift which has happened. Drift is basically 0. Okay, cool. So this is how it works. Do I have to remember all these? Definitely not. How do I write these equations then? Pure geometry, pure logic. Okay, this is Pythagoras, this is trigonometry. This is obvious that distance by this speed only will give me the time, and this speed is completely v. So it's more of obvious things, more of things which you should realize logically than remembering this. If you try to remember, trust me, you will get confused. What was v, what was u? The second case in this is basically shortest time. Is basically I want to reach the other side, but not in shortest distance, but in shortest time, as quick as possible. So again, this is how it looks. This is the two banks. Okay, so think about it, my dear students. Think about it. If I have multiple options, one's like this, one's like this, one's like this, one's like this, one's like this. Every time, let's say the river pulls me here, river pulls me here, river pulls me here, river pulls me here, river pulls me here. The river has only x velocity, it has no y velocity. And remember, the time taken to cross is distance by the y velocity. In this y velocity, the w, which is the water's velocity, w has no contribution, Is that right? Because w is, since it is in x direction, so it has no role in y velocity. So if by chance I want to make this time minimum, what do I have to do? I have to make Vy maximum. If I want to make this minimum, the denominator should be maximum. How do I make the y velocity as large as possible? You make the u velocity only like this. So I think this is when it is maximum. Do you see the y velocity is maximum when you are trying to swim in this direction? River has no role to play. River has nothing to do with time taken to cross. The time taken to cross only depends on the y velocity, and river is going in x. So you try to swim in this direction. You try to swim in this direction. So basically what happens is you end up swimming like this. This is your u. The river will pull you here, but that does not matter because you are using all your strength in crossing the river in as less time as possible, and you end up going here. That's okay. So you will end up drifting, okay, somewhere here. You aimed over here, okay. So there will be an obvious drift which will happen. So in such a case, the time taken, the minimum time that you take to cross will be d by only u over here, d by u, and the drift will be horizontal speed into the time. So horizontal speed is basically just w. There is no contribution from u, it is only w, and time is basically this time. So it will be d by u. That's all. So that's your drift. That's your time taken to cross. If you want to find v, you can also use Pythagoras, and you can say v square is nothing but u square plus your w square. That is using your Pythagoras, right? All these things you can write. Did I memorize this? No. I have written it down logically by looking at the triangle. So always draw the diagram, things will look much easier. Is that okay? Cool. So if you have understood the general case and the special two cases of shortest distance and shortest time, then let's do some questions now. First question, the boat crosses the river perpendicular with a velocity of 8 and the resultant velocity is 10. Then what is the velocity of the river water? That's the question, my dear students. That's the question. Let's try to do this. Okay. First of all, the boat is crossing the river perpendicular like this. So u is basically 8. The resultant velocity is like this, and that is 10. So v is basically 10. Question is, what is w? You can obviously see that this is a right angle triangle and you have to use Pythagoras. So 8 square plus the w square is a 10 square. So w square is 100 minus 64, which is 36. So w is basically 6. So answer is B. Answer is B. Exactly. It's just 6. Perfect. That's how you solve this problem. If you draw the diagram, you don't have to sit and by heart anything. You should go with the flow, go with logic, go with the visualization. Let's go with the next question. Boat is crossing the river width 1 kilometer in the shortest path in 15 minutes. If the speed of the boat is this much, then what is the speed of the river? Okay. So let's again draw the diagram. It will make it much easier. So the distance is 1 kilometer and you are going in the shortest path. That means like this. This will be V. Okay. So this is basically 1 kilometer. So the time taken to cross is the distance by V. So it is 1 by V is basically, how much is the time given? Time is given to be 15 minutes. So 15 minutes is basically nothing but 1/4 of an hour. So what I get is 1 by V is 1 by 4. Time is 1 by 4. Distance is 1 kilometer. V is, I don't know. So therefore I get V is 4 kilometers per hour. The reason why I converted minutes into hours is because I wanted everything in kilometers per hour. As simple as that. Now the person will try to swim like this. So that will be U, and the river will try to pull him this way. So that will be the water velocity. I think the speed of the boat is already mentioned. So U is mentioned to be 5. I just have to use Pythagoras and find W. You can clearly see W square plus U square is equal to V square. So W square plus U is basically, oh sorry, my bad. W square plus V square is equal to U square. So therefore W square plus V is nothing but 4 square is equal to U, which is basically 5 square. So W square will be 25 minus 16, which is basically 9. So W is basically 3. So 3 kilometers per hour is the answer. Yep, there you go. Is that right, everyone? Got it? I'm just using Pythagoras simple geometry, nothing more, nothing less. If you draw the diagram, if you know those special cases, you will get the answer. Moving to the next question coming up on your screen. This is direct question. River is going from east to west. Okay, river is basically going from east to west. Okay, so that is the water velocity. This is your east direction to west direction with a speed of something. Man on the south side, capable of swimming in this much speed, wants to swim in the shortest time. If he wants to swim in the shortest time, okay, and he is on which bank? He is on the south bank. Well, it's very simple, guys. This is the banks and he is on the south bank, that means he is here. If he wants to cross the river in the shortest time, he will direct his strokes or velocity like this. Yes, the river will pull him here, that's okay, and the resultant velocity might be like this. He will end up drifting here, but his actual velocity will be directed in the north direction. So the answer should be north. Exactly, option A. Option A. Is that right, everyone? Very good. If you got it as north, you are good. Very good, guys. Let's move on to the next question coming up on your screen. A boat moves with some speed relative to water, which is flowing with a speed of 3. Width is 1 kilometer. How much time it takes to go back and forth in the shortest distance? So basically shortest distance, that's the question. So first of all, if I draw the diagram, right, the shortest distance is when the net velocity is perpendicular. It goes like this and also again comes back in the same path. Correct? That's what shortest distance means. Now it's clearly mentioned the boat moves with a speed of 5 relative to water. That means U is mentioned. U is given to be 5. The water's velocity is 3. Water's velocity, the river's velocity is basically 3. Can you guys quickly guess and figure out how much will V be? Because V square plus 3 square will be 5 square. So therefore V square will be nothing but 16. Therefore V will be nothing but 4 kilometers per hour. 4 kilometers per hour. Once I know V, I can easily find the time taken to cross the river. Time will be distance by the y velocity. Distance is 1 kilometer. Speed is basically 4. Completely the y velocity is v itself. This is just the time taken to cross, but it is asked clearly over here, time taken to go back and forth. So the total time will be 2 times the time taken to cross. Once like this, once like this. So it will be 2 into 1 by 4, which is half an hour. Half an hour is basically 30 minutes. Option D is the correct answer. Option D is the correct answer. Is that clear, my dear warriors? Everybody with me? Cool? Exactly. Very good, Alekhya, Praveena, Priyanka. Very good, Basmana. Okay. No, it's not C. It's D. Basmana, be careful. It's 30 minutes. Next question. Coming up on your screen, this is a NEET PYQ. Speed of the swimmer in water is 20. Speed of the river is 10. If the person is on the southern side and crosses the river in the shortest path, at what angle should he make his strokes with respect to the north? Okay, let's draw the diagram. Things will be very, very clear. These are the two banks. The water is going towards the east. Okay, standard scenario. The person is on the south bank, goes to the north bank along the shortest path. Along the shortest path. So this is basically the resultant velocity. This is the shortest path. So what will happen is he will direct his velocity like this. So U will be here and the river will pull him like this. This will be the river velocity. Correct? Now it's clearly mentioned the speed of the swimmer is 20. Speed of the swimmer is basically 20. And the speed of the water is also mentioned. I think, yeah, speed of the water is basically 10. Okay. Now question is, at what angle will he make the strokes? So how do I find this particular angle? This is theta. I think you can see this is a right angle triangle. This is opposite, this is hypotenuse. So that means sine theta. Sine theta will be W by U. That means it will be 10 by 20. That means it will be half. So theta will be basically 30 degrees. So basically what happens is you will direct your velocity of 20 meters per second, making an angle of 30 degrees with what direction? North direction. Towards which side? Towards the west side. This is west, that is east. So 30 degrees towards the west should be the answer. Yep, that's the correct one. 30 degrees towards the west with respect to the north. Is that clear? Yep. Perfect. Option D is the correct answer. Awesomeness, awesomeness. Very good. So I think that was the last question. There is a homework question which I am giving it to all of you. Make sure you take a screenshot of this and post the answers after the session is over in the comment section. Okay, I will show you the next question also. I think there is one more. Yes, this is another question. Take a screenshot of this, post the answers in the comment section. I want to see how many of you can get this. Alright, so these are the two questions which I have given you for homework as practice. Try to put up the answers and do let me know what chapter you want next after Newton's laws. Okay, next week I'll be doing magnetism. Alright, we will be starting off with magnetism, and yes, we will be doing simultaneous 11th and 12th portions. Trust me, the entire thing will be covered over here. Okay, and if you want more guidance and more mentorship, you always have the NEET Energized batch where I am teaching. I am taking care of the entire batch physics. Wazim sir and HSP sir are taking care of chemistry. Ambika ma'am is taking care of biology. So make sure you are a part of that batch as soon as possible, so you can get the entire resources whatever are needed for cracking NEET examination. Cool? See you guys. See you in the comments. Bye bye. Have a great time. Take care. Hasta la vista. Captain Slayer.